So this is part 3 of our exponent laws. Now it's a little different than part 2, which was a product of powers. This is power to a power. So it's going to look a little different, and you do something different in order to simplify. So let's look at this table, just like we had the table in the last one. I did the first row for you. Look at column 1. Column 1 is a power of a power, meaning I take a power, which is the base and its exponent, and I raise it to another power. So what this first one says is that I have 5 squared 3 times. So I wrote out 5 squared 3 times. I then expanded that. So I've got 5 times 5 times 5 times 5 times 5 times 5. Just like in product of powers, I count the number of products. I then am going to rewrite it as 5 to the 6th power. So let's go through and look at my next one. This says negative 3 squared squared. So I'm going to write each one out. I then write it out again, and I count my bases. I have 4, so this would be negative 3 to the 4th. Remember what I said in part 2. If there's a negative, make sure you're putting it inside parentheses just the way the base is, or outside if it's outside of the base. Finally, I have a variable. If you look at this variable, I have 4 b squareds. I'm then going to expand that and count how many b's I have. You have 8. So this is b to the 8th. So do you see a shortcut that could get you from the original problem to the answer without the middle columns? I hope you said multiply the exponents, not add. Okay? So product of powers is add. Power to a power is multiply. Now, people get a little confused. Okay? What does that mean? Well, when you have a power and you raise it to a power, you multiply. So here's my power, right? I'm going to take that and raise it to another power. If you go back and look at your notes from part 2, you had 2 or 3, you had multiple bases. Here, I have one base. It's just going to this x. So what I'm going to do is I'm going to multiply. Okay? So I take my power and I raise it to another power. When I do that, I multiply the exponents. Does everyone see what I'm doing here? All right. This one again is just write the expression using each base only once. So I have n to the 4th raised to the 7th. So I'm going to multiply those two and get 28. When I come here, I have x to the negative 3rd times 5. I still multiply the exponents, and I'll get negative 15. Again, like I said on the last time, you could leave it that way, or you could write it as a fraction. Okay, this is the same thing, except there's a couple steps here now because you have more than one exponent law here. Okay, so you're going to simplify and go until you can't go anymore. That's what it means. So first, I would do the power to a power. Okay, what that means is you would do 5 times negative 2. When we do order of operations, exponents comes first. A lot of you might be sitting there saying, Ms. Sintov, they're all exponents. Yes, but a power to a power is an actual exponent. Then I'm going to do product of powers. So I'm going to shift gears. Instead of multiplying them, I now have to add them. But My instructions said to simplify, meaning go until you can't go anymore. Meaning, is there anything else I can do? In this one, I can write with positive exponents. So I would write it as 1 over y to the 7th. To pause the video, I would jot down these things and emphasize that the order in the process matters. And it says to simplify. Write down what simplify means. Go until you can't go anymore. So you always have to ask yourself, is there something else I can do? So here we go. Okay, let's try these together. So first, I'm going to do my power to a power. So 6 times -4 is -24. Then I'm going to do my product of powers. 2 plus -24 is -22. I can't leave a negative exponent, so I have 1 over x to the 22. Okay, my next one. How did I get 21? I multiplied 7 times 3. So now I'm back to my part 2 of exponent laws, which was your product of powers. I add. -2 and 21 gives me 19. I don't have to do anything. It's a positive exponent. I've gone as far as I can go. So the last three we've done, and I say 3 because the previous slide had my power to a power on the back end of my problem. Here it's at the front. Also notice I'm doing a negative times a negative to give me a positive. Then I'm now at product of powers. So I'm going to add my exponents and get r to the 13th. Okay, so we did it with either all the same variable or all the same number. What happens when I've got a variable and a number in there, or I have 2 variables, or I have 3 items in there? Okay, we were doing it where it's just one thing. It doesn't change. We can expand it out like we did. What it meant was I've got that 4m 3 times. Okay, now just like the commutative property, I would group my numbers with my numbers and my variables with my variables. I then am going to write them as a power. And if you can do 4 cubed, do 4 cubed. If you can do 2 squared, do 2 squared. So that's how I got that 64. So let's go through and do this. It says AB to the 4th. What that means is I have A times B 4 times. What I want to do is I want to group my A's together and my B's together. And then I'm going to count how many there are. Well, there's 4 A's, there's 4 B's. So that's my answer. I can't do anything else. There's nothing else I can do. So now I have 3xy squared. Well, what that means is I have 3 times x times y twice. We'll go through and regroup it. You have 3 times 3, x times x, and y times y. Okay, very simple. You have 3 squared, x squared, y squared. Can I do 3 squared? I hope you're all sitting there saying, yeah, it's 9. Okay. Do you see a shortcut that could get you from the original problem to the answer without the 2 middle columns? So as we see from the original problem to the final one, what happened was we multiply each exponent inside by the exponent outside. And there's a big key word there, multiply each exponent. So how is this one different than the one we just did earlier? Well, now what's inside our parentheses, there's more than one factor. So when we take a look here, I have a 3. That 3 is raised to the first power. I have an x. That x is raised to the second power, and I have a y to the 5th. So when I raise a product of powers to a power, I'm going to multiply that cube on the outside by each exponent on the inside. So what happens is I get 3 cubed, x to the 6th, and y to the 15th. Remember, what we're doing here is we're multiplying, which gives me 27, x to the power of 6, y to the power of 15. So that is what your final answer would be. The in between would be our work. So let's go through and simplify. Let's try this. So first I have to look at n to the 5th, and that's squared. So I multiplied those two exponents. But I also have 4mn to the negative 2nd cubed. Again, I'm going to multiply those out. Don't worry about the negative exponent yet. Some of you might be trying to go make it positive. I hold that step off for the end. So now what I'm going to do is I'm going to move things around, and I'm going to put my ends together. It makes things a little easier. And right now, you're going back to the product of powers, okay? So see how you have 2 bases are ends? I'm going to add those exponents to give me a 4. Now, I'm not done. It's almost done, but I have the ability to do 4 cubed. And 4 cubed is 64. I can't do m cubed or n to the 4th. I don't know those variables yet. Now I am completely simplified. And this is why I say don't worry about the negatives yet, because we had to add the negative 6 and 10 to give me a positive 4. Every time you learn a new exponent rule, other exponent rules might pop up in between a problem. So you got to keep an eye out for those rules and really understand them. Well, we're at that time. It's your turn. Pause the video and try these 3 on your own. Pause now. Okay, let's go see what this looks like. So if I start with x to the negative 2nd squared, okay, you should have gotten x to the negative 4th. Then when you cube everything inside the next one, you get 3 cubed, x cubed, y to the 15th. But again, I can move some things around. I have 2 powers with a base of x, so I'm going to put those next to each other. Those exponents I will add. Now there's 2 things I can do here. I'm not completely simplified yet. I can do 3 cubed, but I also have a negative exponent. So with that negative exponent, I have to make it positive. N cubed my 3. That is my final answer. Let's go take a look at our next one. You had 6ab cubed, 5a negative cube squared. So we distribute the 3 to everything on that parentheses and the 2 to everything on the next one. So you should have gotten this. Now, I caution you, and I'm going to pause here for a second. If you don't have every single step I have written down, I would go back and add it in, even if you have to add it in on the back or on a sheet of paper. The reason for this is, if you take your time and break every step down and don't hold something in your head, your chances of a mistake are less likely, but I'm able to catch your mistake and tell you where you're going wrong if I can see your thought process. I can't tell where you're going wrong if I see the problem in an answer. If it's a wrong answer, it's a wrong answer. I don't know what you did wrong, okay? So let's keep going. All of this is being multiplied. So I can use my commutative and associative properties to rewrite things. I can put my number bases together, my A bases together, and then my B. Now, I'm not cubing or squaring anything yet. I just combined my a's. So now I'm down to one of each type. Now I'm going to look. I can cube the 6, and I can square the 5, and I can make that a positive. So 6 cubed means 6 times 6 times 6. 5 squared means 5 times 5. My b cube, he's going to hang out there on the top. He has nothing to combine with, but I moved my a cubed to the bottom. Our instruction said to simplify. I am not simplified yet because there is still something else I am able to do. I can do 216 times 25 and get 5,400. That is now my final answer. I can't simplify anywhere else. So that one was kind of a lengthy one, and it's probably a lengthy one because some people sit there and say, oh my gosh, those numbers are so big. It doesn't matter. You have a calculator. It's okay. Let's go to our last one. I'm going to have to distribute this 4 to everything on the inside and the 3. So you should have 3 to the 4th, c to the 20th, c to the 6th. This one's a little more straightforward. All I got to do is combine my c's, and then 3 to the 4th is 81. So that is my final answer. Now, some of you might be freaking out, and that's okay. Right now, more than ever, is when you need to take time to reflect and summarize, or comment below. What part of this did you not get? I get the comments. You guys know that. Or when you come in tomorrow, ask me, or send me a message on Remind, or email. Whatever it is that you need. That way, we can target the specific problem where you're going wrong when we practice this in class.